Let us welcome Tejas Shende. He is IIT Bombay, students of IIT Bombay, and he is majoring in mathematics with minor in computer science. He has attended, he is two-time Indian Mathematics Olympiad Awardee, and he has attended the senior batch of INMO in 2022. He has received the offer for undergraduate admission in University of Cambridge and University of California. He has secured JEE Advanced rank 552 and KBP rank 39. So let us welcome Tejas. Over to you now.
Right, so before we begin, a quick show of hands. Uh, how many of you are in class 10? 9? 8? Correct. Is everyone able to read what I've written here, or should I write bigger? Is there anyone who's not able to read what I've written there? You're not able to? Alright, I'll write this bigger. Okay, so this is how we're going to proceed. First, for those of you who are comfortable with trigonometry already, you can try the two problems given in the left. On the right, I'll go over the basics of trigonometry and quickly we'll develop tools that will help us solve the problems given in the left. Okay, so starting with what is trigonometry really? Does everyone know what's triangle? Yes. So a triangle is any geometric object with three straight lines, that has three sides and three vertices, right? Right. Can anyone hear me? Alright. So a triangle is an object with three sides and three vertices. Does everyone know what is a right triangle? Yes. So it's a triangle which has one angle equal to 90 degrees. So in general, let's call it triangle ABC. The ordering is important because the vertex B has 90 degrees, so it's not the same as saying BAC or CBCA. Here we call, let's call angle BAC equal to theta. What is theta? It's a variable that encapsulates the value of the angle. That is the measure of angle BAC is equal to theta. Alright. So in trigonometry we define quantities known as sine of theta and cos of theta, which is respectively given by before that when we have a triangle ABC, opposite to vertex A we call the side BC as small a, we call the side AC as small b, and the side AB as small c. Is everyone comfortable with this? Yes. So I'll just write this here. Side then BC is equal to small a, and similarly for the other two sides. So we define sine of theta as the ratio A over B, that is the opposite over the hypotenuse. Similarly, we define cos of theta as C over B. Notice that this implies the moment we define a ratio, we are able to do so because every triangle which has an angle as 90 degree and another angle as theta has the same ratio of sides. Why is that? Because every triangle which has one angle theta and the other angle 90 will be similar. By which criterion? Right, AA property. That is, if two angles of two corresponding triangles are equal, then they are similar and the ratio of the sides is equal. So any triangle which are right triangle which are y angle theta will be similar to all the. So in this manner we create a family of triangles having y angle 90 and y angle theta, and in such triangles we define this ratio sine of theta as opposite over hypotenuse and cos of theta as adjacent over hypotenuse. C by B, correct? So now can someone tell me what is the Pythagoras theorem? Perfect. So it says that the sum of square lengths of the sides is equal to the square length of the hypotenuse. In this case, the hypotenuse is B, correct? So we can say that Z square plus A square is equal to B square by Pythagoras theorem. So is everyone fine with this? Right? And we know that all of the sides of a triangle, so A, B, C are all non-zero and positive. So I can divide both sides with the same positive quantity. So what I do is I divide both sides by the quantity B. Doing so, what will I obtain? I'll obtain that C over B, the whole square, plus A over B, the whole square, is equal to, what is this quantity? 1. Perfect. Now what is C over B? Cos of theta, correct. What is A over B? Sine of theta. So thus we have a first identity for the line, that is cos square theta plus sine square theta is equal to 1. This identity is true for all angles theta. So in mathematics we write this symbol which implies for all. So when I write cos square theta plus sin square theta is equal to 1 for all theta that are in angles. So I can say for all theta greater than equal to 0, right? So where they can be in degrees or radians. By the way, does everyone know what's a radian? No? Alright, don't worry, we won't go there. So we'll stick to degrees for this time, for this class. So the first identity we have is cos square theta plus sin square theta is equal to 1. Perfect. Now we'll go about defining a few more ratios. So you can memorize this or get familiar with this, but the fact of the matter is we have a couple more ratios known as tangent of theta and cotangent of theta. They are abbreviated to tan and cot. So what tan is defined as the opposite over the adjacent. So we have A over C, and because we can divide both sides by B, we get that this is equal to sine over cos. Correct? Does anyone have any objection with this? No? So similarly, cotangent of theta is defined as the reciprocal of tan of theta. So in actual sense, we define it as the ratio of the adjacent over the opposite, but I'm skipping that because it's very obvious from the first definition that follows. Thus, we get that this is equal to cos theta over sin theta. Similarly, we have two more ratios which are less used, so we won't see them. Then we won't most likely see them again. We define something called a sec theta. That is the sec of theta is defined as the multiplicative inverse, that is the reciprocal of cos theta. So similarly, we have another ratio called as the cosecant of theta. This is defined as the reciprocal of sin theta, right? So now that we have all the four ratios, know that the two important ratios are derived directly from the angular sine and cos, and using these both, we can derive the rest of the ratios, that is tan, cot, sec, and cosec. And importantly, using this relation, we can say that if we have the sine of an angle, then using this identity, we can find the cos of the angle as well. And once we have the sine and cos, we can find all the angles. Correct? Yeah. Notice that all the discussion we have done so far is valid only for a triangle, which means that in a right angle triangle, what is the minimum maximum value theta can have? Well, minimum is obviously 0, so we can say 0 is less than theta. What is the maximum value theta can have in the right angle triangle? 90, perfect. And can theta ever be equal to 90? No, because if it's equal to 90, what we get is straight line, and we never get triangle. We effectively have two parallel lines, correct? So for the entire discourse that we've had so far, 0 is less than theta is less than 90. Alright? Cool. By the way, everyone's comfortable with English, right? So very quickly, we'll generalize the notion of an angle to the entire circle. That is, so far we have only looked at theta from 0 to 90. Now we look at theta from 0 to 360. How are we going to do this? Well, basically we encapsulate the fact that 360 degree implies a full circle. So we draw something known as a unit circle. That is a circle centered at the origin with radius 1. By doing so, we get this figure, and in this figure we redefine our quantity of sine and cos by calling them as the coordinates of any point on this circle. What do I mean by that? Here. When I say that this is a point on the unit circle, let's say this is the point P. We have the coordinate plane xy, right? Everyone knows what's the coordinate plane, correct? So every point in the coordinate plane has two coordinates, x coordinate and y coordinate, correct? So we call this P of x comma y. So because this coordinate lies in the unit circle, it implies the distance of P from origin is equal to 1. So what relation can I get between x and y which ensures that the distance OP is equal to 1? Correct. We can use distance formula to say that square root of x minus 0 the whole square plus y minus 0 the whole square is equal to 1. Correct? Squaring both sides, we get that x square plus y square is equal to 1. Does this look familiar to you? Have you seen something similar on the previous board? Yes. We have seen that the sine of an angle squared plus the cos of an angle squared is equal to 1. So what we do is we assign the value of y coordinate to sine and the value of x coordinate to cos, and say that any point in the unit circle, consider the angle that it makes with the x-axis, positive x-axis, right? This angle, you can notice that every point in the unit circle will make a unique angle with the positive x-axis, right? For example, if I take this point, then the angle will be with positive x-axis. It will be this obtuse bada angle, right? Is everyone comfortable with that? Is everyone able to see this? I'll draw it a bit bigger. Right? So we have a unit circle, any point P with coordinates x comma y, we satisfy this relation, this origin O, x-axis, y-axis, and we define the angle with positive x-axis, that is x-axis on the right, as theta. Then this line OP makes an angle theta with the x-axis, and we define x as cos of theta and y as sine of theta. So by doing this, we basically have the values of sine of theta and cos of theta for every angle in the circle. So what is the range of theta here? Obviously the minimum angle is 0. What is the maximum value theta can take over the entire circle? 360, perfect. When a point goes around the circle once, we get 360. But notice that while theta can be equal to 0, it can't be equal to 360 because 360 and 0 are effectively the same thing when you come look at the position. There is a point that makes an angle 0 and a point that makes an angle 360 are the same. So we have this as the range of theta this time around, and using this, by considering an angle between 0 and 360, if we project a line which makes an angle of theta with the positive x-axis, the line meets the unit circle at a point B with coordinates x and y, then x is the cosine of that angle and y is the sine of that angle. Correct? Is everyone fine with this? Right. So we have defined cos of theta and sine of theta for higher angles, that is angles beyond 90, and now we generalize it to all theta, that is theta belonging to real numbers. How will we do that? Well, basically we define, we say that consider theta mod 360. That is, if we have an angle of 420 degrees, that is equivalent to say it's an angle of 60 degrees. Why is that? Because notice that when I say 420 degrees, after every complete revolution, you arrive at the same point origin, right? So when we see that we revolve around the circle once to arrive at the origin, after that every angle we take will be a repetition of the angle we've already taken. So this implies that theta is equal to 360 plus theta for any. Similarly, we can take n number of rotations. It won't matter. Any angle is basically equal to n plus theta. So this implies that we have another identity with us. Sine of 360 plus theta is equal to sine theta. Similarly, cos of 360 plus theta is equal to cos theta. Is everyone fine with this? Yes? Alright. You can note this down. So now we'll look at a few problems based on what we've learned so far. But before we do that, I'll show you a couple more identities that follow directly from sine square plus cos square equal to 1. So we have identity for all theta again. Yes. Divide both sides of this by cos of theta. What will you get? Sin square theta by cos square theta plus cos square theta by cos square theta equal to 1 over cos square theta. Agreed? Fair? What is this? Tan square theta. What is this? 1. What is this? Sec square theta. Perfect. So we obtain that if this is true, and this is indeed true as we have seen, this implies this. So tan square theta plus 1 is equal to sec square theta. This is a second identity, right? So because this is an identity, this is also an identity. So this equation is true for all theta, and that's why we call it an identity, right? And similarly, if we divide by sin square theta instead of cos square theta, we get another identity that looks like this. 1 plus cot square theta is equal to cosec square theta. Alright? You can check this. Divide the original equation sin square and cos square equal to 1 by sin square on both sides and you will obtain this. How will you prove that? You can use these relations and substitute them back to the original equation to obtain this. Right? So now, how many identities do we have? We have 1 the original sin square plus cos square. We have this as 2 and this as 3. So we have 3 basic identities. Alright? You should always remember them, and basically these two are just cheap rip-offs of the basic first identity that is important, sin square plus cos square. Remember, whenever you see a question with sec and cos and cosec and all those things, you can try to reduce it down to sine and cos alone because you know that all of these angles can be expressed in terms of sine and cos. Correct? Yes. So remember that. Although, moving on, when you see complicated questions, you'll notice that it is not always wise to reduce sine and sec and cosec into sine and cos because that increases the complexity of what you're trying to solve. What am I trying to say? I'll just show you in a minute. So we have a basic trigonometry and 3 identities in place. So we can try a couple of questions. Your job is to simplify this given equation on the board. This is absolutely constant equation, which you realize when you try to simplify by expanding the terms. And then you will be able to solve the first question. Well, understandably so. So listen up. Well, we notice that sure we know what sine square plus cos square means, but we don't know how to deal with higher powers of sine and cos, right? For example, we have sine to the power 6 and cos to the power 6 here. So how do we take care of these? Well, we have a couple of big cute identities that will come very handy to us. So before proving this, try proving what I'm writing on the board now. Alright, so we ignore the questions for a while. Let's start proving this. Cos to the power 4 theta minus sin to the power 4 theta is equal to 1 minus 2 sin square theta. How will we do this?
Sir, we can apply the identity. A square minus b square is equal to a plus b times a minus b.
Perfect. Using that, what do we obtain? You can take, as you said, a square minus b square is equal to a plus b into a minus b. Everyone is aware of the identity, right? So here, put a is equal to cos square and b is equal to sin square. This equation, that is the left hand side, reduces to cos square minus sin square multiplied by cos square plus sin square. Why? A minus b into a plus b. Correct? What is this?
1.
1. Perfect. What do we have remaining? Cos square minus sin square. So can you find a way to go from here to here?
By using sin square plus cos square equals 1.
Perfect. By using that, you can write cos square as 1 minus sin square. And when you do that, you notice that 1 minus sin square minus sin square. That is, this and 2 times gives you 1 minus 2 sin square 3. Right? Perfect. Does anyone have any doubt in how we obtain the first equation? And write this properly for you to copy. Although I won't be writing the next two down, that will be your job. Normally, when you're trying to prove mathematical statements, what you do is you take, if you have to prove that two sides of an equation are equal, you start from the LHS, you perform certain manipulations on it, and reach the RHS. Right? That is the conventional way of proving. However, in general, we know that mathematical equalities work both ways. So, if you're able to find a way from RHS to LHS, that's also fine. But if you're able to find a way to go from LHS to some certain quantity and RHS to that same quantity, even that's fine. Because A equal to C and B equal to C implies A is equal to B, right? So all these are ways of proving two things are equal. Using this, now how can we prove the second identity?
Sir, we can add 2 cos square sin square theta and subtract 2 cos square sin square theta.
Perfect. And why would you do that?
Sir, to make sin square theta plus cos square theta whole square minus 2 sin square theta cos square theta.
That's absolutely brilliant. So that's precisely what we have to do. Notice that यहाँ पे, if you can say, if you call A as equal to cos square theta and B as equal to sin square theta, then this equation is basically A square plus B square is equal to 1 minus 2AB. Is everyone able to notice this? Right? And when you see this, what's the natural thing to do? You can add 2AB to both sides to obtain what? You 2AB goes from here, you get 2AB यहाँ पे. And what is this LHS? A square plus B square plus 2AB. Perfect. It's A square A plus B the whole square. Plus what we get? A plus B the whole square is equal to 1. This is what we have to prove, right? But what is A plus B?
Sin square theta plus cos square theta.
Yeah, and what is that?
1.
Perfect. So we get 1 square is equal to 1. Is this correct? Brilliant. So we have found a way to go from this equation by adding 2 sin square theta cos square theta to both sides to obtain 1, and thus we have 1 equal to 1, which is a true statement, which means we must have begun the true statement to begin with, and that proves this identity, right? In a similar way, try putting A equal to cos square theta and B equal to cos sin square theta to prove this third identity. Does everyone know what A plus B the whole cube is?
Q plus PQ plus PA square B plus
Perfect. So we have A plus B the whole cube as this. Everyone's fine with this? Yeah. What is A cos square theta? B sin square theta. So what is this? 1. Brilliant. So we have 1 is equal to A cube plus B cube plus, I can group these terms to look like 3AB into A plus B. Is everyone fine with this? And what is A plus B again? 1. Brilliant. So we get 1 equal to A cube plus B cube plus 3AB. So can I write A cube plus B cube equal to 1 minus 3AB? I can. Is everyone comfortable with that?
Yes, sir.
Yes. Which means that this identity A cube plus B cube equal to 1 minus 3AB would imply this. Why? Because our A is cos square theta and B sin square theta. So when we put cos square in A cube, we get cos to the 6 theta. Similarly, we get sin to the 6 theta equal to 1 minus 3 sin square theta cos square theta. Is everyone fine with whatever you have done so far? Take a minute, note down everything that's given, and ask if there are any queries. Those of you who have understood what I've just said can try the first question now. That will be a lot more doable. On? Yeah, that's correct. 6 is right.
so that one is 7.
Perfect. This one is 7, and the next one is 6. Good job. So, now that we have solved these questions, would you like to tell how you solved the first one? Yes. The lad who said first question is done. Would you like to explain how you simplified the equation? Who said 7? Yeah, you. Then how you simplified this?
First I did sin theta plus cos theta square, then square on top of that.
Right.
So first I got sin square theta plus cos square theta plus 2 sin theta cos theta.
Alright, sin theta is S and cos theta is C. To save space, because I don't want to write too much. We have S plus C the whole power 4, which he said he wrote as S plus C the whole square, come whole square. You can expand the inner square.
1 plus 2 SC.
Perfect. 1 plus 2 SC. Why is that? Because 1 is equal to C square plus S square. Right? So we can write S plus C the whole power 4 as 1 plus 2 SC the whole square. Perfect. Then
We can expand this also. 1 plus 4 S square plus 4 S.
right, we can do this.
And then it
Yeah.
cancels out with
Perfect.
the
What is this? You've just seen in the previous tree that sin 6 theta plus cos 6 theta is equal to what?
1 minus 3 cos.
Right. सब लोग एक बार बोल दो बस. Sin to the power 4 theta plus cos to the power 4 theta is equal to what?
1 minus sin square theta cos square theta.
Good. And sin to the power 6 theta plus cos to the power 6 theta is equal to what?
1 minus 3 sin square theta cos theta.
Good. Remember this. So whenever you see such equations, substitute this right away. It mostly makes your job much easier. Sin 6 theta plus cos 6 theta is what? Like you all said, is 1 minus 3 s square c square. We get minus 4sc in the question, which gets cancelled, like we said, with the initial term, then plus 5 minus s square c square,
Which also gets
which also gets cancelled. Is minus 3 minus s square c square plus 4 s square c square. I'll write this here. We have 1 plus 5 plus 4 s square c square minus 3 s square c square minus s square c square. What does this fetch you? It gets you this getting cancelled. You get the answer as
5 plus 2.
correct 1, 1 and 5. I lose the 1. That gives you 7. Perfect. Nice. So that takes care of the first question. Second one, who said 6? Right. Would you like to explain?
So we have to go cos square plus that question into the form A plus B.
Perfect. That's what you have to do. Notice that we are given sin square theta plus sin theta is equal to 1. Have you seen something similar as an identity?
Yes.
You know that sin square theta plus cos square theta is equal to 1. Using this tell you, they say that cos square theta is equal to sin theta,
Yes.
right? You can. So when we write cos square theta in that form, you get that if you can write cos square theta equal to sin theta, so cos square theta is basically sin to the power 6 and s6 plus 3 s5 plus 3 c4 plus 3 s4 plus s cube plus 5. Now, like I said, we can you know that the expansion of a plus b the whole cube is a cube plus 3a square b plus 3b square a plus b cube. Correct?
Yes.
So in these, you notice the coefficients being 1, 3, 3 and 1. So can you see something similar happening here?
Yes.
Right? You see 1s6 plus 3s5 plus 3s4 plus 1s cube. So a wise thing to do would be, fine, so yes, yeah. We can take s cube common and we can write s cube plus 3 s square plus 3s plus 1. Everyone fine with this?
Yes.
What is this?
S plus 1 double.
S perfect. You just see the binomial theorem and you know that this is equal to s plus 1 the whole cube. Couple this with this, what do you get? S square, s into s plus 1 the whole cube. What is s into s plus 1?
S square plus
S square plus s, and what is that equal to?
1.
1. Perfect. So we get that this entire thing simplifies down to just 1. So we left with 1 plus 5, which is equal to 6. So are you clear with how we tackle both these questions? Yes? Note this down, let me know if there are any queries. See, basically in trigonometry, when you are trying to solve questions, it's not a lot of actual memorization, you just need to know what the basic terms mean. But after that, it's basically algebraic manipulation. For example, in the first question, we need to expand all the terms and then use this identity, which came from the fact that a square minus b square is equal to a plus b into a minus b. And then this cubic thing came from the identity A plus B the whole cube. So if you're comfortable with your algebra, that is the identities that you have taught in middle school, that is A plus B the whole square, A plus B the whole cube, A minus B the whole cube, and so on, you'll find all this much easier because that is very directly used in solving these problems. So I recommend that you should go over your algebra book once again and be comfortable with the identities so that you can apply them as and when you see. Right? Have you written this down? I mean, honestly, you can just take a photo, I guess, that'll be easier and faster. You have a lot of stuff to cover. We're not allowed to bring your phones. That's fine. Okay. So, right, just note down the method and the trick you're using because you can write the details down at home, right? This stuff is not hard to do. You can do the addition, multiplication, division by yourself. Just write down the trick and few. For example, you have to expand and add. You have to create a cube and cut out, right? Cool. So, now that you're done with this, if you can move on to, and now that we also know how higher angles work, we'll see a few identities that are useful. What we call identity, they're basically this relation between sine and cos. So, move this won't take much time. Right. So we saw that trigonometric angles can be defined for theta between 0 and 360 and beyond because like after 360 it just loops back to the original position and you can subtract 360 out of the angle. So using that we have something called as the sine of an angle. So I mean not sin wala, the plus or minus sign. So very quickly, you know that the coordinate of a point in this quadrant, you know what's a quadrant, right? It's what? Positive and positive, right? Like every point in this quadrant will have positive x coordinate and positive y coordinate, right? In this coordinate, what's the case? Perfect. So we have the signs of coordinates in these quadrants. Now, remember how we defined sine and cos for the entire circle? We said that the x coordinate will be equal to cos of theta and the y coordinate will be equal to sine of theta. Tell me where is x positive? In this quadrant? First and fourth, correct? So x is positive in first and fourth quadrant, which implies that cos of theta is positive in quadrants 1 and 4. Well, what is the angle for quadrants 1 and 4? It is basically 0 to 90 and
270.
perfect. It's cos theta is greater than 0 if theta is equal. Have you all seen the concept of intervals? No? Well, I'll just quickly tell you. If we see that 0 is less than theta is less than 90, this can be represented by saying theta belongs to the interval 0, 90. Okay? This is just notation. Are you comfortable with this? Like, these both statements are equivalent. Alright? Similarly, 0 less than equal to theta less than equal to 90 is equivalent to saying theta belongs to open interval 0 to 90. I'm sorry, closed interval. When we have parentheses, that is rounded brackets, we call it an open interval. But we don't include the terms 0 and 90 in the interval. Whereas when we have closed brackets, that is square brackets, we call it a closed interval. That is 0 to 90 closed. But the 0 and 90 are both included. You can see that when we say less than equal to and less than equal to here, similarly when it's less than and less than, right? So this is just notation, nothing fancy, don't worry about it. You'll get familiar with it soon. So you keep this in mind. And now cos theta is greater than 0 if theta is in first and fourth quadrant. First quadrant way, you know theta belongs to 0 to 90, barabar, and you can take its union 270 to 360. Right? You know what's a union? When we have two sets, if you take the elements of both the sets combined, that's a union in vague sense. This is a set, this is a set, union is this entire set. Cool? Right. This is basic set theory. This will be covered by a different professor pretty soon, so don't worry about this. This is notational jargon. But notice that writing this union format is pretty itchy for me because I have to go push around the circle and then niche se aate. But you can see that the continuous loop from bottom to top. So instead, I can write theta belongs to minus 90 to plus 90. Is everyone comfortable with this? I can see that 270 is the same as saying minus 90 and 360 is the same as saying 0. Why can I do this? Because we know that any angle after 360 loops itself. So we can also have negative angles. That is minus 90 is the same as minus 90 plus 360, that is 270. Similarly, all numbers in this range can be subtracted by 360 to obtain minus 90 to 0. So we can see that theta belongs to minus 90 to 90. Right? This is the range and cos theta is positive. Similarly, now tell me where is sin theta positive?
The first and second quadrants.
In the first and second quadrants. So what are the values of angle for which this should have been?
0 to 180.
0 to 180. Perfect. So are you comfortable with this? Yes. Similarly, using these both, we can tell where tan is positive.
First and third.
Perfect. First and third. This first quadrant may cos is positive, sin is positive, and third quadrant may cos is negative, sin is negative. So in the division, it is positive, right? Which means this here we clearly have disjoint intervals, so we have to use the union notation. That is 0 to 90 union 180 to 270. Right? Now you might think, what is the use of all this? Well, there's really no use of this. It's basically to help you understand how sin and cos behave over the entire graph. So, using this, we can now draw something called as a graph of a function. Very quickly, what is sine of 0 itself? 0, because sine is the y-coordinate of a point, and at the x-axis, the y-coordinate is 0. So sine of 0 is 0. We have this point in the graph of sine. We're basically plotting the graph of sine of theta, where theta is on the x-axis and the value of sine is on the y-axis. At time t, when you're at the top, what is the value of sine? Sine is basically the y-coordinate. Remember, when I'm asking you sine of something, I'm asking you the y-coordinate of the point when it goes around the circle. So at time t, the point is at the top. So what is the y-coordinate of this point? 1. So I can say sine of 90 is equal to 1. Right? Similarly, when I'm back at 180, what is the sign? 0. At 270, what is it? And back at 360? 0. Now we have 4 points in the graph. Well, I'm going to tell you something that you have to take for granted now because you don't know what is a continuous function. But continuous basically means I should be able to draw the graph of the sine without lifting my pen. That is the marking. So when I try to draw the graph, it ends up looking something like this. Right? This is what it looks like between 0 and 360. Now tell me, because angles repeat after 360, how will it look after this point? Same. It will basically repeat itself over and over. Right? Is everyone comfortable with this?
Sir,
Yes?
sir, why not the graph is linear? Sir, not linear like why it is curved between 0 to 90? Why it's not the
Right. It's curved between 0 to 90 because it's also something called as differentiable. So again, that's some jargon you don't need to worry about. So differentiable basically means that the curve is smooth. So what smooth effectively means in geometric terms is at every point on this, I should be able to draw a tangent curve to it. What does a tangent mean? A tangent is any straight line that touches the curve at only one point. What do I mean by touch? It basically means that if I have a curve like this, tangent will cut the curve at one point and one point only. For example, if I have a circle, this line cuts the circle at 2 points. So it's not a tangent. But this line touches the circle at only one point. So it's a tangent. Right? Similarly, I should be able to draw a tangent at any point on this curve. Correct? So if, like you said, if you have something like this zigzag curve of sine, ऐसा कुछ अगर होता, then at this point you wouldn't be able to draw a tangent, right? Because यहाँ this side से we are going up, this side से we are going down. The tangents will not match. So this curve is known as not differentiable. That is, we can't have any sharp corners on the graph. Again, it's irrelevant to what we are trying to discuss here. It's basically that you can take from me, you can take it from me that the graph of sine looks like this. What does it mean? It means that if you take any angle, say 75, 125, then you can find the value of sine of 125 by taking the graph of sine or marking 125 on the x-axis, projecting it upwards, and then finding the value where this point has its y value. Finding the y value of this point will cut the graph upwards. So इसका जो भी y value होगा, that is the sine. This value is the sine of 125. Similarly, any angle on the x-axis, if I consider its value, take the sine of this angle and then take the y value. The y value will give me sine of that value. Correct? This angle, अभी मुझे किसी भी angle का sine निकालना है, तो I can mark in the x-axis, take its y value and read the graph. Right? This is basically known as reading the graph. Similarly, to conclude the graphing process, how will the graph look like on the left? Same. Just उल्टा कर दो इसको. That is, इसी part को वापस यहाँ पे डालना है. यहाँ पे similarly it goes on endlessly to the left and the right. Correct? Fine. Using this graph, can we make a few simple conclusions? Can you notice that as we go ahead of zero, that is on this side, we go उतना ही नीचे as we go behind zero, right? So if I say I want sine of 30, it will effectively be equal to sine of minus 30 का minus value. So I can say sine of 30 is equal to minus sine of minus 30, right? We can generalize this to say that for all theta, sine of theta is equal to minus of sine of minus theta. A more convenient way of writing this is by taking minus from here and putting it here. Using this, we can now find the values of all negative signs. That is, if you want a value of sine of minus 30, just take the sign outside, that is the minus outside, and you get minus of sine 30. That is the value of sine minus 30. Right? In general, any function that satisfies the property f of x, f of minus x is equal to minus of f of x is known as an odd function. Why odd? There's no real reason, it just looks odd, right? So f of minus x is equal to minus of f of x. If a function satisfies this property, it's known as odd. Very clearly, sine is odd, right? Similarly, now we can draw the graph of cos theta. When I want cos, what do I really want? I want the x coordinate of the point that moves around the circle. What is the x coordinate of the point when theta is equal to 0? 1. Perfect. Cos of 0 is equal to 1. When I go to 90, we are at the top. What is the x coordinate here? 0. At 180, what is the x coordinate? Minus 180. So I'm sorry, minus 1, right? And again at 270, what is the x coordinate? 0. Perfect. So again, because sine cos is basically a brother of sine, this graph looks similar. What do we mean by similar? It's differential between all points you plot on the graph. So we have 4 points. Starting from here, I'll draw the graph, and I'll tell you it looks something like this. Similarly, on the negative side, when I'm in positive, x coordinate is a. When I'm, it's going to reflect this on the x-axis. You get the same x value each year, right? So you can see that sine of a negative, cos of a negative value is the same and the cos of a positive angle. Correct? Why is this? Well, I should prove it, but more importantly, you can intuitively see this because when I am in a circle, if I reflect my point about the x-axis, the x-coordinate does not change. This point simply has its y-coordinate getting flipped. The x-coordinate remains as it is. That is why the x-coordinate will stay the same, and we have plus theta becoming minus theta. So this implies the cos of minus theta is the same as cos of plus theta. Genuinely, if you are unable to understand what I just said here, it's not an issue. Just copy down the graphs and you can go home and take a careful look at them as to why they are behaving the way by using what the initial definition I've given. That is, the cos of any angle is the value of the x coordinate of the point where an angle makes with the x-axis. Right? This is the definition of cos and sine. Using this definition, you can reproduce the entire graph at your home by yourself. You can try doing that, and using this graph, you'll be able to see that these conclusions hold. End of the day, you have to remember this fact. Minus sine is equal to sine of minus, and cos of minus is equal to cos. In general, functions that satisfy f of x equal to f of minus x are known as even functions. You all know what is the modulus function? Mod of x
It's the absolute.
is basically the absolute value, that is the positive quality of it. For example, mod of 4 is equal to 4, mod of minus 3 is equal to 3. Cool? This is basically defined as equal to x if x is positive and minus x is if x is negative. Alright? So, ignoring all this, mod of x you can verify is also an even function. Why? Because mod of x is equal to mod of minus x. That's also the criteria for an even function. Right? So these are what we have learned now about the functions sine and cosine. As an extension, I write a few more properties on the board that are useful for you to know, and so basically you can prove them very easily by using all that you have seen so far, that is the positioning of sine and cos in the unit circle and the graphs of sine and cos. But I won't prove them here because that will take a bit too much time, right? So first we have sine of 90 minus theta is equal to cos theta. An intuitive way to see this is basically by looking at a triangle. If this is theta, then 90, and this is 90 minus theta, बराबर. तो इसका साइन क्या होता है? This opposite by hypotenuse, and cos of 90 minus theta क्या है? Adjacent by hypotenuse, same ratio है, बराबर. That implies they're equal. Similarly, you can switch 90 minus theta both sides to get cos of 90 minus theta is equal to sin theta. I would write that here, but that's pretty obvious. Then we have sin of 180 minus theta is equal to minus sin theta. No, it's equal to plus sin theta, sorry. Sin of 180 plus theta is equal to sin of minus theta, that is minus sin theta. Sin of 360 minus theta, that's equal to minus sin theta, basically what I've written there. So 360 is 0, it's equal to minus sin theta. And lastly, we have something called as a period, that is the value after which a function repeats. You just see that the graph of sine repeats after 360 degrees, correct? That is known as a periodic function. So you don't need to worry about the terms right now, but just know that the period of sine is equal to 2 pi of 360 degrees. That is sine of 360 plus theta is equal to sin theta. That is after every 360 degrees, the value of sine repeats itself. Similarly, cos of 360 plus theta is also cos theta. Right? You've just seen this on the basis of circle. So in the circle, after 360, the angles repeat themselves. Right? Cool. So sine of this is the sine 360 plus theta is sin theta. Cos of 360 plus theta is cos theta. This is the period. These are easy equalities. Nobody can ask them. The important ones are these. Sine of 90 minus theta is cos theta. Sin 180 minus theta is sin theta. Sin 180 plus theta is minus sin theta. And sin 360 minus theta is minus sin theta. Yeah. It's a lot to digest in a small amount of time. So I suggest write this down, read this over and over. Before you speak, read this again. You don't need to memorize it in one go, but eventually once you use it over and over again, then they get internalized in your working, and when you're trying to solve problems, you use this again and again. For example, if I now ask you to find sine of angle 135, how will you do it?
Sin 90 plus 45.
Perfect. You can either do 90 plus theta or 180 minus theta. I can say sine of 180 minus 45, and using this equality, I know that this is equal to sine of 45. What is that? 1 over root. Perfect. Similarly, we can now find big angles coming sines. For example, something like sine 360. 360 equals to 0. You can find sine 405. What will that be? Sine of 360 plus 45. Perfect. That's again equal to sine 45. That's 1 over 2. Right? So using these, you can find the sine of all angles above 90, above 360, anything. Basically anything. Right? And I'll write the last one. Sine of 90 plus theta is equal to cos theta. You can very easily notice that these inequalities are true by looking at the graph of sin theta. I'll quickly show you how. Again, graph is never a proof of anything in mathematics. We only use graphs to help us understand better what's happening in a given function, right? So it helps us internalize what's going on in the function, and you can intuitively see what's happening. What is the sine graph of sine? It's something like this, correct? This is the graph of sine, right? This is 90 angle, this is 180, 0. Notice that after 90, this identity says that sine of 90 plus theta is equal to cos theta. What does that mean? Sine of 90 plus anything is equal to cos. Can you see that if I remove this part of the graph, this is identical to cos, right? Because what is the graph of cos? It's basically 0 से ऐसे, बराबर? This is the graph of cos. So if I remove 90 and value of plus sine, it's basically identical to cos, correct? Is everyone able to see that? Right. That is why this here sin 90 plus theta is equal to cos theta. Again, I reiterate, there is a lot of proof of this identity. This is basically just to help you understand how this is happening. And in order to prove this, you can use the original definition I've given, all the identities that you have. Correct. So now quickly moving on. Oh, level 6 already. Like, we'll quickly look at compound angles and end the lecture. I don't think we'll be able to reach till here, but at least ये वाला हो जाएगा. So I'll discuss this question and that will be about it. Okay, so what do I mean by compound angles? Well, basically, any angle that's written in the form of sine of a plus b, when a and b are angles, are known as compound angle, right? So this angle is known as a compound angle. It is basically compounding the angles a and b. So now I know the values of sine of b, the basic fundamental numbers in terms of theta, that is 30, 60, 90, 45, 75, so on. But now I want to find the value of each angle, such as say 15, which is equal to 45 minus 30. I know the value of sine and cos of 45. I know the value of sine and cos of 30. Can I find the value of sine of 15? Well, yes, I can. How is that? We first look at how we can find the identity cos of a minus b, and using this, we'll be able to find all four identities. How? We'll see. First, let us try to find an equation for cos of a minus b. Again, as we know, trigonometry being a unit circle, so we'll draw a curved unit circle. and you know that A minus B is an angle that is drawn from the x-axis. Barabar? But I have one more way of finding the angle A minus B on the unit circle. What is that? Well, first you can draw A, that is the bada wala angle. This is A, and then you can draw B on the same angle. That is niche. This is B. The big one is A, small one is B. Can you now see A minus B forming between two rays in this picture? Correct? This is A, this is B. The bacha wala angle is A minus B. The angle we care about. Correct? When I say I want to find the value of cos of A minus B, what I basically mean is I want to find the x coordinate of A minus B when but the x coordinate is the point which subtends an angle A minus B at the origin. But notice that यहाँ पे मेरा x axis is नीचे, but A minus B is not around the x axis. So what can I do? I can shift the entire system by an angle B downwards to get this ray to coincide with the x axis, this ray to coincide with something niche, and the niche part will be a point of my concern. How? I'll draw this out. This is my unit circle. And now, after shifting the system by V degrees, just say rotating, not shifting. Rotating the entire system by B. This side is clockwise, so clockwise rotating this thing by B. I obtain that this is now around the x-axis, and my ye wala ray is now here. With the angle A minus B. Are you comfortable with this? I'll label my points to help me out. This is O. I'll call this B. I'll call this Q. I'll call this R. I'll call this S. Fine. What are the coordinates of S? Unit circle.
1 0.
1 0, perfect. So I have 1 point. Now notice that if I have a given figure and rotate it by certain quantity, will the length of this change? No, the length remains the same. So I can see that the length PQ and the length RS. Will these lengths change? No. If I rotate a quantity by certain angle, the length will remain the same. So, by principle of rotation, we have that PQ will be equal to RS. And now, we're in luck. Why? Because notice that the point P is on the unit circle, subtends an angle P. So, what are the coordinates of P? By definition of cos and sine, P is on the unit circle, subtends an angle of P at the origin. So, what are the coordinates of P?
Cos B and sin.
Lovely. Cos B and sin B. Similarly, what are the coordinates of Q?
Cos and sin.
Cos.
Perfect. Then cos A and sin A. Do we know something called as the distance formula?
Yes.
We do. So can you tell me what is the distance PQ?
Cos.
Again, the expression is simplified.
2 cos square B minus cos square A plus
Right.
2 sin square B minus.
Cos B minus cos B the whole square plus sin A minus sin B the whole square. The whole thing to under. Correct? This is PQ. Now what is RS? Because by definition, R is on the unit circle, subtends an angle of A minus B at the origin or along the x-axis. What are the coordinates of R?
Cos A minus B. 95.
Cos A minus B and sin A minus B. Now can you see these quantities emerging, right? In terms of cos A and sin A. You have that on one hand, PQ is equal to RS, so cos A minus cos B the whole square plus sin A minus sin B the whole square under root is equal to, what is the length of RS now? Distance formula RS y1 minus y2 to the whole square, x1 minus x2 to the whole square, cos phi 1 0, then
Cos A minus B minus 1 whole square. Yes.
perfect. Cos B minus B minus 1 the whole square plus sin A minus B minus 1 the whole square.
Minus
That's 0.
0.
Oh, sorry, minus 0 the whole square. Correct? Simplifying this, we have something बड़ा सा formula on the left hand side. We'll ignore that. Both square both sides. We'll have cos square 8 minus 2 cos 8. I'll just write CA CB to CA some space. So if you run short time. Right? This is what the left hand side looks like and expanded. Correct? What is C square A by S square A? 1. What is C square B by S square B? 1. Done with this. And now for the RHS, you have cos A minus B minus 1 the whole square. What does that look like? This is cos of A minus B the whole square minus 2 cos A minus B plus 1, right? And what is this? It is just sine of A minus B the whole square. Correct? What is this? 1. Lovely. So we have 2 minus 2 cos A minus B is equal to 2 minus 2 into cos A cos B. Sorry, cos A cos B plus sin A sin B. Correct? From here and from here we have this identity. Barabar? So 2 goes off, minus 2 में plus हो जाता है, this also 2 gets cancelled, and you end up with the identity that tells you cos of A minus B is equal to cos A cos B plus sin A sin B. That concludes this proof. Fine. I'll go over the proof quickly once again. Drop your pen, listen to me, then you can write this down. You have the unit circle. Unit circle पे any point का x coordinate is the cos of that angle in subtended to the positive x-axis. Y coordinate is the sine of the angle subtended to the positive x-axis. We have to take a point P which represents an angle B with the coordinates which coordinates are cos B and sin B. Take a point Q whose coordinates are cos A and sin A, so it represents an angle A. The angle between them is A minus B. Now take this system, rotate the entire circle clockwise by B degrees. What do you get? You get that this OP coincides with the x-axis OS and the line OQ coincides with OR. That is the line we care about. The angle is A minus B. The coordinates of R are cos A minus B and sin A minus B. Correct? So, and because we are rotating the figure, that is in some sense, you can say triangle OPQ is congruent to triangle OSR. You can prove this easily by using SAS, this radius angle radius. So, using the congruence rule, we have triangles congruent. So PQ is equal to AP by CBC by CBCD. PQ is equal to RS, right? So PQ is equal to RS implies we can use distance formula now. PQ can be computed by doing the distance formula cos sin A cos sin B, and RS using distance formula on cos A minus B sin A minus B and 1 0. We do that as simplification, and we end up with the formula that tells us cos of A minus B, that is angle A minus angle B, is equal to cos A cos B plus sin A sin B. Good. Using this, now can you tell me what cos of 15 is? Right? It's cos of 45 minus cos of 30. Correct? 15 is 45 minus 30. Right? So it's cos 45, cos 30 plus sin 45, sin 30. Quickly, tell me what are cos 45, sin 45, cos 30, sin 30? 1 by root 2, root 3 by 2, 1 by root 2, 1 by 2. Perfect. What does that give us? It gives us, right, root 3 plus 1 by 2 root 2. This is a very important number because it is pretty important. Cos of 15. And now using sin square plus cos square equal to 1, can you tell me what sin of 15? Yes, you can. It's basically 1 square root, positive square root of 1 minus cos square 15. Why positive? Because remember 15 is in the first quadrant. And first quadrant, what is the sign of what is the sign of sign? It's positive, right? So sign of 15 is a positive number, so it's square root of 1 minus cos square 15. Barabar? And there we are. Any doubts with compound angle wala part? Cool. Perfect. So I think that will be it. Huh? Time. Oh, perfect. Alright, then sure. So you can write all those down, and if you have any queries, just let me know. Others. Right. So we have the cos of a minus b is equal to cos b plus sin sin b. So we can find with this. So using this, can you now tell me without going through the entire thing again, what is cos of a plus b?
Cos
Using
equals
this.
to minus
Cos A
Right. So how will I go from here to here? What substitution will I make?
make b as minus b.
Perfect. Put b as minus b, you'll get minus of minus b is plus b. So still using that, and you know cos of minus b is what?
cos B.
Cos b. The sine of minus b is
Minus sin B.
minus sin b. So using that, you get that cos of b plus b is equal to cos b minus sin sin b. Similarly, in order to go from cos to sin, what will we do? What substitution can we make? Remember how you get from sine of 90 plus theta is equal to cos theta? Similarly, you can put sine of 90. यहाँ पे you can put b is equal to 90 minus b, not equal to b goes to 90 minus b. You put what? Cos of b simply becomes cos of 90 minus theta is equal to sin theta, बराबर? Because we know the identities that sine of 90 minus theta is equal to cos theta, and cos of 90 minus theta is equal to sin theta, बराबर? Using this, you can put b as 90 minus b and obtain sine of a minus b. And once you have sine of a minus b, what can we do to get sine of a plus b? Again, put b equal to minus b, and you will get a sine of a plus b identity in terms of sine a minus b. Is everything clear so far? Right? We got this identity. We put b equal to minus b to get this last one. Then we put b equal to 90 minus b to get the second last one. And then we put b equal to minus b again to get the third last one, the second one. Right? Cool. You don't need to write this, you'll find this in any standard book, there's no rocket science. But importantly, we'll cover something interesting here. Sure, these are the compound angles of sine and cos. Now, how can we do the same for tan? Well, what do we know? Tan of what do we know? Tan of theta is equal to what? perfect sin theta by cos theta. So I can write tan of a plus b as sin of a plus b over cos of a plus b. Cool, right? And using this, what do I know? I know that sin of a plus b is what? It's using here sin a cos b plus cos a sin b. And divide the whole thing by cos of a plus b. What is that equal to? Well, that's cos a cos b minus sin a sin b. Don't worry about memorizing them. As you go along using them in questions, you will realize how these work. And it's not that hard. It's just 4 units, like in addition to all the ones you have. Go ahead, don't worry. So now we have a formula of tan of a plus b in terms of a and b. But now I want this in terms of tan a and tan b alone. So what can I do?
Sir, divide by sin and cos b.
Okay, let's try that. If we divide by sin a cos b, we get 1 plus sin a cos b. This will be cos a by sin a will be cos a. This will be tan b. Then sin a cos b, so this will become tan a. Cos b will be cancelled. This thing will become tan b. So, right, we're almost there, but instead we have a third term here which is not that lucrative. So what we can do is we can instead divide by
Say cos.
perfect. We can divide by cos a cos b, and what will that give us? That will give us
Tan A plus
tan
tan B
a and b barabar
by
I'm
1
sorry.
minus tan A.
tan a plus tan b divided by
1
1
minus tan A.
minus tan a and b. Perfect. Now what do we have? We have tan of a plus b in terms of tan a and tan b. Tan of a plus b is tan a plus tan b divided by 1 minus tan a into tan b. So you can add this formula to a treaty of compound angles you already have. We have this formula. And similarly to get tan of a minus b, what do we do? You can put b equal to minus b. So sin of minus theta is minus sin theta. Cos of minus theta is cos theta. What does this tell you about tan of minus theta?
Minus tan B.
Perfect, minus tan theta. Divide both equations, you will get this. Tan of minus theta is equal to minus tan theta, so b becomes minus b, and cos of minus b, so b becomes minus b, tan a plus tan of minus b becomes minus tan b, and similarly tan of minus b becomes minus tan b, so minus of plus becomes plus. Minus of minus becomes plus. Tan of a minus b equal to tan a minus tan b divided by 1 plus tan a tan b. Again, another equation you can add to your kitty. It's not odd, but this step we'll put aside for now. That's all we have to do in theory. Now let's look at a problem we can take from here. You have to evaluate 1 over sin 45 sin 46 plus sin 46 sin 47 plus so on till the end. Where the end is what? The end is 1 over sin 134 sin 135. What is that? So notice this is a humongous expression. How do we go about simplifying this? What common feature can you see in every term? Forty-five, 46, 46, 47. What is the common feature in every term?
Consecutive numbers.
Perfect. The consecutive numbers, which means the difference is what?
1.
1, right? 45 and 46 is 1, 46 and 47 is 1, so on till the very end. So, we can have a stroke of brilliance, and what I'm about to do is something a bit unintuitive to you right now, but it will be pretty useful as you see in evaluating series. What we do is we create something known as the telescoping series. How do we do that? We'll multiply both the numerator and denominator by sine of 1. Why did I do that? You will soon see. Sine of 1. Bahar, and then sine 1 by niche, whatever this is, sine 45, sine 46, sine 47, and so on. But now I'll do something smart. I'll write sine of 1 as not sine of just 1, but sine of 46 minus 45 divided by sine 45 sine 46 plus sine of 47 minus 46 divided by sine of 46 sine 47 and so on till the end. Now, what can we do? You can use compound angle formula sine of A minus B to simplify sine of 46 minus 45. What will you get? You will get sine 46 minus sine 46 cos 45 minus cos 46 sine 45 divided by sine 46 sine 45. That ends up reducing to tan 46, tan 45 minus tan 46. Similarly, the next term will reduce to tan 46 minus tan 47. Then you have tan 47 minus tan 48. And you see something happening here. Tan plus 46 minus 46 cancel. And plus 47 minus 47 cancel. Plus 48 minus 48 cancel. And so on till the very end. Right? So what will be the last term we get? We get tan 134 minus tan 135. Notice that 134 is there in the previous term, so 134 will get cancelled, but 135 will remain intact. Tan 135 is what we get left, tan 45 is what we get left. So the series in the end evaluates to what? It evaluates to tan of tan 45 minus tan 135 over sin 1. Why over sin 1? Because remember, when we multiply sin 1, we also have to divide by the same quantity in order to keep it same. Okay? Now what's this? Tan 45 is what? 1. 135 is what?
1.
Minus 1. Whatever. Use the formula that you have, sin of 90 plus theta, 90 minus theta, and so on. Sin of 1, we don't care. Let it be simple. What do we get? We get 2 over sin of 1. That is our answer. Perfect? Right. Normally in examination, in order to inspire the multiplication assignment, you can be asked evaluate k into sin of 1. You'll notice that where k is equal to this. So when you see that you want k into sin of 1, what you can do is you can multiply sin of 1 already and see what this turns out to be. Right? So yeah, that's about it. Any doubts in this question? Quick run through. What we did was we first multiplied and divided by sine of 1. Then we wrote 1 as the difference of the two terms 46 minus 45, 47 minus 46, 135 minus 134. So on till the very end. Right? And then we used compound angle formula to expand sine of 46 minus 45. Stuff got cancelled. Good for us. Then again we got tans. Tan also got cancelled. Also good. And we ended up with tan 45 minus tan 135 divided by sine, which evaluated 2 by sine. Now a question, an important question here is, how could you predict that these terms will cancel and you will get something nice and cute in the end? Yeah, that's one. Well, normally in series, when you see the denominators are following a certain pattern, 90% of the times what you have to go and do is create a telescoping series. That is, create a series of terms which get cancelled one after the other like a following domino chain, right? And that helps us get this. In reality, there is no real motivation or inspiration you can have to multiply and divide by sine 1, but the only thing you can do is play around with the numbers, see what can help you. Now you have to create plus and minus, and you can see difference is 1. So when difference is 1, it's a good idea to multiply and divide by the difference of whatever denominator you have. Right? For example, a common theme we have in sequence and series is evaluating this series. So on till infinity. How will you do this?
Partial fraction.
Sir,
1 minus 1.
sir, multiplied by 3 minus 0 in the first term.
3 minus 0. Okay. How will that do? Right. So look up. What you can do is, like I said, you can always take care of the differences of denominators. And what does that give you? You can write 1 as 2 minus 1, then 1 as 3 minus 2, 1 as 4 minus 3, and so on. What does this give you? This gives you 2 over 2 minus 1 over 2 plus 3 over 2. I'm sorry, what? Yeah, means 3 over 2 into 3, that's equal to 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5 and so on. So can you see half minus half and plus half gets cancelled, minus 1/3 plus 1/3 gets cancelled, minus 1/4 plus 1/4 gets cancelled and so on till the very end. So what we are left with will be 2 over 2 that's equal to 1. This entire series, there is 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4. This entire thing evaluates to 1 alone. Cool? This is known as telescopic series, which is beyond the topic, but trigonometric functions are so involved with telescoping that it's hard to cover the topic without mentioning. So this is a series that you see soon, like over and over again in this camp, and other better professors will be able to explain the series better. But what I had to do here was I could use the knowledge of this series to solve this particular question or trigonometric function that allowed me to make use of the difference of denominators to cut down by the cancelling terms and eventually end up with 2 over sine. Nice? Cool. And before we go, we can take a look at property of tan and we'll take a look at this question and that will be it. We'll cover it. We know this identity, do we? Yes? So, notice what happens when A plus B is equal to 45 degrees. What does the LHS become? 1. Perfect. So, tan of 45 is equal to 1. So, we have tan A plus tan B. Find the denominator. Transpose this to the other side. What will we get? We will get a denominator 1 minus tan A tan B is equal to tan A plus tan B. Where is this part cool? Right? We used A plus B equal to 45, put this here, we got 1, and this thing became 1, and then we transpose denominator to the LHS to get 1 minus tan A tan B equal to tan A plus tan B. Fine? Now transpose everything to the RHS, what do we get? We get tan A plus get tan A into tan B plus tan A plus tan B plus 1 equal to 2. Is everyone comfortable how we go from here to here?
Minus.
Yeah, I mean, what we get is minus 1 equal to 0. I add 2 to both sides. Why you will very soon see. By adding 2, this becomes plus 1 and this becomes 2. Cool. So, this is what we have. Now we can do something interesting. Notice that you can take tan A common here, the way you do in quadratic equations, to get tan A into tan B plus 1. And here you have 1 into tan B plus 1. Is this correct? So what is this entire expression looking like?
Tan A plus 1 is tan B plus 1 equal to
Perfect. So we have tan A plus 1 into tan B plus 1 is equal to 2. So what do we get? We get that if A plus B equal to 45 degrees, then tan A plus 1 into tan B plus 1 is equal to 2. Using this, can you solve this question for me now? Right? So can you find tan 1 plus 1, tan 2 plus 1, so on, multiplied till tan 44 plus 1?
To the power 22.
Okay. Do you think it's 2 to the power 22? Is this correct? Yes, sir. 23. Alright, let's see. So what do? Well, we can do something known as Gaussian pairing. What is that? Basically, is nothing but pairing the extreme ends of any given series. So how do you do that? You can pick the last term and the first term. What is tan 1 plus 1 and tan 44 plus 1? 2. Perfect. Why is that? Because a plus b is equal to 45. As you can see here, tan 1 plus 44 is equal to 45. This is equal to 2. Similarly, we can go on and define 2's how many times? Till we reach tan 22 plus 1 into tan 23 plus 1. Correct? This is also equal to 2. Right? So what do we end up getting? We have tan 1, 2, 3 to 22 as a smaller term, barabar. So we have total of 22 2's, which gives us the answer of 2 to the power 22. Right? Is everyone fine with this? Cool? Alright, so I think that's about it for the session. If you have any queries on anything I covered today, just let me know. You can reach me at this email ID. Right? And have any queries, you can email me, that's easier to reach me, or you can just let Shugla know and they'll reach out to me with any doubts you have. This question is something we did, and this is a question you'll find in the sheet that Sarita on the circulate. So, good luck with it. Also, the test is kind of hard, so don't worry if you're unable to solve too many. Just pick a question, and if you find it easy, try it. That's all I'll say. Don't worry about the score. It's really not important for you to score high at this point. This is basically almost a JEE level sheet that you're about to see. So you don't have to worry too much about the questions that you'll encounter. Just whatever you've learned so far, try to apply it in the best possible manner in the sheet you see. Right? Don't worry about maximizing your score. Just pick up any question and try the best you can. Right? Don't be disheartened. Good luck.
Thank you, Tejas. Thank you. Tejas, I can see the board and I can see how enthusiastically you have taken this class. Thank you. So now we will have a test. Let me tell you. Let me tell you one thing. We are going to conduct this test daily. Okay?